Hello, my name is Bill Trail, and I'm with the Elkhart Model Railroad Club, and this is Clinic at the Club. Tonight I thought I was just going to give you a simple demonstration of how I use a servo on my model railroad. But in figuring it out, it really turned into more of a production of the amazing Arduino boards and what you can do with them. I don't know if you guys remember the last clinic I gave. It was about AnyRail, and I was designing my layout, right? Not a very big layout. I think I showed you a picture of it. But it turns out that there were 31 turnouts on that layout. And I didn't even put any industries into it yet. And I started doing some math, and I thought, my goodness, point control, that's kind of going to be expensive, you know, just on this layout. And I was trying to figure out a more affordable way to do that. And it turned out, well, let me show you here. The first thing that's pretty common is tortoises, right? We're all pretty familiar with them. They're tried and true. I happened to get this one about 10 years ago when Valparaiso Hobbies closed down. But it's basically got everything you need to control your point from underneath the layout. Of course, they're a little bit large, right? And there's really two ways you can set them up, vertically or horizontally. So that's one option. They cost about $19.99 retail right now. Actually, $24.99 retail. Yankee Dabbler had them for $19.99. So multiply that by 31, you get a big number pretty quick. Another option I considered was, well, a manual control like this Bullfrog. And again, this is another option that would fit underneath your layout. It's not controlled by any electricity at all, right? It's manual. Pretty easy to install, but then you still have to be concerned about, your bench work, where things are going to line up, and you've got to figure out how to do control. These run $10 retail for this unit, but when you start adding in all the other costs like the knobs and rods that you need to throw them and all the work you have to do to get them in, they're a little bit expensive too. You can get those at fasttracks.com. Another option I considered was the tried and true caboose round throw. Simple, holds the points open or closed. Some guys think they're a little bit overscaled, right? They're a little bit big for line side hardware, but when it comes to it, they're right on your layout, and if you have to reach across, you might knock your cars off the track. And some guys think they're a little small for big fingers. But that's an inexpensive option. I think you can get these, for $2.80 each, and this was at yankeedabbler.com also for a 5-pack. It turns out to be like $2.80 a piece. Pretty inexpensive way. That wouldn't be a bad way to go. But then the last option, and was looking at, was the whole idea about using inexpensive servos, SG90 servos, to throw my points, right? Real versatile. 10 of these on Amazon, $18.77. That's $1.87 each, right? So pretty relatively inexpensive compared to all the other options. So in looking at that, the question became, all right, I've got the servo. Now how do I control this servo on my layout, right? So that's where the Arduino comes in, and that's really where I was amazed to learn what all you can do with an Arduino controller. What is an Arduino? An Arduino is, this is an Arduino Uno controller board, and it's a lot like a computer, but it's not a computer because it doesn't have a processor in it. What it is, it does one thing over and over very well, but it's similar to a computer in that it uses code. You write code, and unlike a computer that could do many different things, the Arduino is designed to do one thing over and over and over again. So it's simple in that sense, and the fact that you actually use code to run this thing is what makes it so powerful, because that one thing, you can write a very complex little code to do a very complicated little one task over and over again. But for this project, I decided to use Arduino's the Arduino board to control my servo. Some other things about Arduino: it was actually designed as a teaching tool for people to learn about circuitry and components and control that weren't necessarily programmers. So it's very easy in that sense. It's an educational tool. So because we're using code, the code what they call the codes, they're written in C++, which is a very well established common programming language, when they set up Arduinos initially, the code was open source. So that's a good thing. What that means is that there's no cost to use their interface to write the code. And additionally, you can share it, which is really good for model railroaders. Model railroaders like to share their ideas, and the cost of entry then is very low, and the learning curve is very short too, because there's a lot of good people out there explaining how these things work. So that's one of the neat things about the Arduino controllers. Additionally, they're very flexible with regard to power. They don't need track power to operate. They can work directly off of a computer serial cable. You can power them off of a 9-volt battery if you want to. They run at 5 volts. There's a 3-volt source in here as well. I've got the setup here running off of an old phone adapter, an old phone charger adapter. So they're very versatile as far as powering goes. And then additionally, well, they're relatively inexpensive. This is the probably the most common Arduino board. It is the Uno. It probably retails. This is about $25 if you got an actual Arduino. One of the great things about these, there are a lot of compatible boards online now that are essentially the same thing, but they're a lot cheaper. This board is probably about $17. I happen to get this in a kit, a starter kit for Arduino. This kit was a little bit expensive. It was $54, but it has just a lot of components involved in it that is actually like it was originally intended to teach you how to use these things. So there's lots of sensors and different components in there that came in my kit. So in a nutshell, that's what the Arduino board is. It's a controller that actually controls your, in this case, a servo, but it can control a lot of other things on your railroad. And as I started to research this, I was just amazed. I mean, it can control your servo motor. I'm going to use it for point control, but this can be used to animate different things. I can control DC motors, simple DC motors, things that hobbyists that we know about. Sensors like here's a circuit sensor, a lot like one of the BD20s I think that you've seen, but this is actually I could use for current detection and hook this up to my Arduino for current detection. I've got sensors, infrared sensors. Here's an example of an infrared sensor. So I could utilize something like this, like we do for like crossing gates or crossings or block detection if I wanted to. And here's just another version of a current sensor that doesn't use the rectifier here. So those are some different examples of different types of sensors you can use. There's also things that that are like inherently Arduino. For example, this Arduino, it has a few limits. It's in size. The Arduino, this is the common Arduino. They make one that's a little bit bigger than this. They call the Mega, which is approximately twice the size as far as input pins and output pins. and also storage for code. They also make this nano version, which is a smaller version. All three of these different Arduinos do the same things. It's just the capacity. This one's a little bit smaller. In addition to that, there are things that you can add to your Arduino that make it really powerful. They call them shields. So you could put a shield on top of your Arduino board, and it's designed to plug right into it. This is just a blank shield for prototyping, but they make shields to incorporate Bluetooth, Wi-Fi, various things like that. There are motor shields. So really there's quite a variety of Arduino shields for whatever task you're trying to accomplish in your project. I've got one for my Mini that I'm going to be using, which is just a hookup board, basically it mounts your Arduino on top, and you've got screw terminals now instead of having to solder or use DuPont wires to connect to the bottom. So this makes installation of my nano boards a lot easier. But those are shields that you can use. In addition to that, you can expand the power of this little board by adding other things. This is an expansion board that's designed to give me more inputs and outputs. So if I hook that up to my board, I can just use one of the pins on here and actually link up maybe 60, 70 buttons to this one little controller now, and expand the Arduino that way. Another expansion board that's going to be really important in my layout project is this one here. This is actually a servo connector, and it's designed to actually run your servos off a separate power source. And this little board can actually connect 16 servos. So I hook this board up to my Arduino, and I can connect now 16 servos to the limited pins on here. So this, for design and expansion and flexibility, is a real powerful thing. And then beyond that, beyond the expansion boards and the components that are designed specifically for the Arduino, there are other things in our hobby that are important. Things like JMRI and DCC+. These are, you can connect directly to JMRI and operate your entire railroad through an Arduino. In fact, this can actually replace the need for buying a DCC ProCab from NCE, for example, or a Zephyr from Digitrax. You can actually design your entire command station with an Arduino, and you would do that using JMRI and or DCC+. Those are all advanced things that I've learned, and this is the stuff that's that there's a lot of guys out there that give great information about that. I'm not going to explain all those things to you. The problem I'm solving today is just very simple, and it's just to find a way to throw this turnout. So after looking at the cost of entry and the expandability of the Arduino, I thought, wow, that's definitely the way I think I should go. So here's my servo control project and the steps that I've taken with it. There's a couple things. First of all are the parts. Let me clean this up a little bit here and show you the parts for the installation I've done here on this board. Let me just show you the parts that I've used. I'm using an SG90 servo, and this is probably the cheapest servo you can get. And if you're not familiar with what servos are, I mean, it's a motor that drives typically 180 degrees, and you just tell it where you want it to go, and it'll go to that point, left or right or what have you. There are a few servos you can get. This happens to have plastic gears in it. Pay a little more money, you can get one with metallic gears. There's all sorts of servos you can find. But for my purposes, and I'm actually modeling an N scale, this will be ideal. And this will work as well, as you'll see for HO. But the servo is one thing. I'm going to be using the nano board and one of those shields that I told you about. going to be using a piece of wire and a piece of U-channel, aluminum U-channel, and a button. Can't forget about the button, and a momentary push button. So those are the components that I'm putting together. To do this little mock-up here. Before I installed it here, and I don't have it hooked up this way, but I used a breadboard to test out my circuitry. The breadboard is one of the things that comes in the starter kit, along with a lot of other neat little tutorial projects. But the breadboard is the place where you want to build your circuitry and test it out. It's also your opportunity to test out the code, because you'll hook up your Arduino to this board. It'll be your opportunity to test out the code that you're running and make sure you have everything right. You use wires to hook it up, and they're very quick connections, but they're not very solid connections. So to transfer this to your layout, it would not be reliable. In fact, I had an experience recently where I was over at one of Ken's house, and we were going to try to get this to work on his layout, and I hadn't done it beyond the breadboard, and we were going to just try to hook it up real fast using the breadboard, and it just was not reliable we couldn't maintain the connections well enough with this. So the breadboard's important though, because it gives you the opportunity to experiment, to learn new things, and test out your theories in what you're trying to do. So that's the next step. Third step is actually modeling it. And so in modeling it, it's really just hardwiring. This is such a simple demo, but I'm going to show you here. The caboose runs through the straight, right? And when I press this little momentary push button, the turnout changes to the diverging route, and there you go. It's that simple. Press it again, and it returns it back to straight. It's a very simple operation. Now, to accomplish that, one thing you'll notice, I built up some sample bench work here, but I only used two inch joists here. So you can see that the components that I put together kind of look like this. Very similar to the tortoise in a lot of ways, or the bullfrog in a lot of ways. What I do is actually, what I'll do is I'll take this servo and I'll set it up so it's at 90 degrees, and then I attach the arm so that it points straight down. I'll put a Z-bend into the wire, right, and then I've actually cut some holes in here. That small hole there at the top becomes my fulcrum, right, and I'll put that together like that. And that's what we have here. Now, one small modification that I made to my servos, I don't know if you can see that little lip there, or that little nub for mounting it. I had to shave that off or cut that off with a razor saw so that it would fit flush into the mount. One thing that's kind of cool about these mounts, this is just standard 1/2 inch aluminum U-channel. It's very close in size to the width of the servo. In this particular case, I had to just put a little piece of styrene in there to hold it. It just press fits in there, right? So it's very easy to mount it once you get this hooked up underneath your layout. So here you can see I've got it mounted, and when I press the button, you can see Can you see the operation? Just like a tortoise, right? So now that I've got, really the important thing about modeling it this way is I've kind of established a process now where I can go and repeat this on the layout. I know exactly how it's intended to go in, what I can do with this. I mean, I set this up about 2 weeks ago, and it's operated flawlessly ever since. And it's all just, based on the code on that board. All I have to do is plug it in and it works. There's nothing else. So I can test it, break it, and know that it's going to be close to flawless on the layout when I get it in place. So that's the importance of the steps in the project that I took. Now, there's a couple things that you might be thinking about here. One of the things that our tortoise enables us to do is link the turnout for power routing, for signaling and things like that. This is a very simple implementation here, but one of the cool things about these servos is they come with a variety of armatures that you can add to them. And what I plan to do for power routing, for actually routing power to my frogs, is to put a mechanical switch and just have another rod actually trigger it when I throw my servo, and that'll route my power. So, I mean, that's one way to do it. I could also find ways to code into my Arduino to route power too, through different methods. But that's one thing. Another thing is signaling. If I want to protect this crossout, I could just tell the Arduino when it throws to the divergent route to, light up a red LED that I have mounted right here. So those are things that are very, very possible to do with just some simple coding. So, pretty basic. The costs of, I mentioned at the beginning some of the different costs. What I put together here in the presentation, it might be hard to read it on the screen, but I'll make sure that you all have this posted on the group's IO, or if you want it emailed to you, I can email you the presentation. But I've got a list of the costs here for the components that I showed you today. The ones at the top of the list, the first four, are the components that I'm using on this. So the button, the board, the nano board, and the servo, and that's really it. So who's good at math? If we add those up, we're under 10. Well, we're just over $10, and we've got an automated turnout. Competes pretty well with the other ones, especially when you consider the fact that this scales up pretty nicely too, because all I have to do is add some other components, which I've listed the prices for there, and we've got a pretty affordable project for automating our layout. There are a lot of really good online resources for Arduino. Arduino.com, actually .cc, I don't know what that really stands for, but that's their website. It's educational. There's forums online there that, any question you have, somebody's going to have an answer for you. You could learn a lot there. Beyond that, Groups IO has an Arduino for Model Railroaders group, and they post regularly, similar thing, but these guys are doing it just for model railroading. NMRA has a section on their webpage, I didn't put a link to it, which has pre-built Arduino projects that you can, take and update for your own layout. YouTube is an incredible source for learning quickly, because there's a lot of model railroaders like us out there explaining this stuff in more detail than I am today. I've actually, Little Wicket Railway has a lot of very interesting projects where he automates his railroad and servos, but instead of throwing them with a push button, he's got it set up to where he can actually operate them through JMRI. And I've actually set it up that way at home on a breadboard. I didn't do it for this presentation. Beyond that, DIY and Digital Railroad is a great website. what he does is he actually explains the sensors he's going to use, the steps he's going to take. Then he actually writes the code right there for you. But he's got a great sheet. He says at the end, the whole thing's down there if you want to just take it and use it. So that's a really neat thing. But if you really want to go step by step and write it out the way he does, you just follow along with him. You can do that. But he's got a lot of different things with block detection and things like that. And then there's Ron's trains and things. I haven't really watched too many of his yet, but there's really just a lot of resources for Arduino. These are the railroad specific ones, but there's really just a lot of sources for Arduino code and doing different things that you want with Arduinos. So thank you guys for listening to me kind of give you an overview of Arduino controllers, what they are. They're cost effective, really flexible, and I mean they let you operate and animate your railroad to your wildest dreams. Thanks again for coming to the Clinic of the Club. I'm Bill Trail with the Elkhart Model Railroad.